Section 3.2 is about extrema in the first derivative test. So what are extrema? Well, we call them extrema, and this book uses the word relative. I've also seen the word local used, so you might hear me say local or relative interchangeably. An extrema is a highest point or a lowest point within a given interval. So that's the formal definition of a relative maximum and a relative minimum. A relative maximum would be the highest point in a given interval. For instance, relative maximum would be this point right here. A relative minimum is a lowest point in a given interval. For instance, this point right here would represent where a relative minimum or local minimum occurs. One thing to notice looking at this page is a maximum occurs when a function changes from increasing to decreasing, and a minimum occurs when it changes from decreasing to increasing. Again, remember from the previous section that a function is increasing when its derivative is positive and decreasing when a derivative is negative. What this next picture is emphasizing is if you have a relative extrema, such as a relative maximum pictured here, we notice that that relative extrema must occur at that relative extrema. The derivative is either 0 or at a cusp like this, the derivative is undefined. And any point where the derivative is 0 or the derivative is undefined was called a critical number or a critical value. So that's where they get this statement right here stating that if f has a relative minimum or a relative maximum, then it must occur at a critical number. One thing that I've seen several students get confused about is what do they want when they actually ask for a relative extrema. There's three different ways that we can write or explain relative extrema. A relative extrema occurs at a point on a graph, x, f of x, where x is the x value, f of x is the y value at that point. One way that they can ask the question is what x value does the relative extrema occur? We just read a theorem that stated that x value must be a critical value. Another way that a question might ask is what is the relative extrema? What they're looking for then is the actual y value. They want the y value of the point. That is the highest or lowest value. The x value is where it occurs. The y value is the highest or lowest value. And a third way that I've seen it asked is just straight up wondering, what's the point on the graph? In that case, you would give an ordered pair as your answer. So depending on the question, some questions want just the x value, the relative extrema, the x value where it occurs, which again must be a critical value. Another question might want the maximum or minimum value, which is just the y value. And a third type of question might actually want the point on the graph. So the big question becomes, how do we find these relative maximum or minimum? To do this, we're going to use the first derivative test. This is one of the methods that we can find relative or local extrema of a graph. Here's what it says essentially. If we have a function that's decreasing and then increasing at a critical value right there, that point, we know that point must be a relative minimum as long as it's defined in the original graph. Again, if a graph is increasing and then decreasing, and there's a critical value in between them, that point must be a relative or local maximum. Again, increasing and decreasing means when is its derivative negative and when is its derivative positive. So if we do a sign chart like we did in the previous section, and we see that a derivative, f prime of x, goes from negative to positive at that point, and you have a critical value in between there, we know that that critical value, because it goes from decreasing to increasing, must be a minimum. We also know if we're looking at a sign chart and we're looking at that derivative, and that derivative goes from positive to negative at a point, we have a critical value at that point. That means it was increasing then decreasing, making that point a relative or local maximum. One thing that it does state here is it says if on both sides of the critical value it's positive or both sides it's negative, we can't conclude that it's a maximum nor a minimum. So that's what the first derivative test is. Do a sign chart like we did in the previous section for determining increasing and decreasing, and then just make one more step of interpretation. If it goes from negative to positive, that's a minimum. If it goes from positive to negative, that's a maximum. So putting that together with what we learned in the previous section, we have the following process. First thing we're going to do is find the derivative, find the critical values. We create the number line, we test 1 point in each interval, just like we did in the previous section. But the new part of this is interpreting your solution. Not only are we going to say when the derivative is positive, it's increasing, when the derivative is negative, it is decreasing, we can now also determine if those critical values are relative maximum or minimum. That critical value is a maximum if the derivative changes from positive to negative at that point, and that derivative is a relative minimum if the derivative changes from negative to positive at that point.